Let's talk about the last graph, that is acceleration versus time graph. Again, the things to remember are the acceleration is a vector quantity, so any acceleration which is taking place in positive y direction is positive and along negative y direction is considered to be negative. Time is an independent quantity, so to be plotted on x-axis, acceleration on y-axis. Again, this is the graph for this spring mass system which is oscillating in y-axis. Okay. Now again I will make a point that here time is equal to 0. This is 1/4 oscillation. This is half the oscillation. This is 3/4 of the oscillation, and this is one complete oscillation. Right? We need to investigate the different values of acceleration. So first of all, what I am going to do is, we do know the fact that velocity was a omega cos omega t. Right? Now this is the velocity as a function of time. I am going to differentiate this. So dv by dt, that is equal to d by dt of a omega cos omega t. Now this is the acceleration. In which axis? Velocity is changing in y direction, so the acceleration itself is in y direction. Now a and omega are constants. Amplitude, this is 2 pi by t, the angular frequency, so these two are going to come out, a omega. And cos function's differentiation with respect to time is sine omega t, but negative. D by dt of cos omega t is minus sine omega t. Applying the chain rule, differentiation of omega t is omega. So the acceleration is minus a omega square sine omega t. Just rearranging this a little bit, ay is equal to minus omega square a sine omega t. By the way, what is a sine omega t? This is minus omega square y, because you know that the equation of displacement is a sine omega t. So here a sine omega t, I am simply writing this as y. Okay. Now we will use this expression to plot the graph, right? Okay. Now let's look at this particular graph. Here the value of y is 0. Here the value of y was plus a. Here the value of y is 0. The displacement from the mean position is the displacement measured. So from mean position, this is at the extreme positions. Let me write down this extreme position. Extreme position. This is mean position, mean position, mean position. Right? This displacement is maximum but in negative direction. Now I am simply going to write the ay is equal to minus omega square y. Just now we derived this expression. Okay. So now let's plug in the value of y. So I am getting acceleration as 0 because y 0. So I am getting acceleration 0. So what can I write down? For time 0, displacement was 0 and the acceleration along y-axis was 0. So this will help me to plot the graph. At time 0, acceleration is 0. So I'll plot my first point. At time 0, the acceleration is going to be the 0. Okay. Now let me bring back the paper and explain you the rest of the other parts. Here at time t by 4, correct, 1/4 of the oscillation gets over, and what do you have? You have y is equal to plus a. So acceleration is negative of omega square. Instead of y, I am going to put plus a. So the acceleration is going to be negative. I am not going to plot this. Please wait, you will understand why. At time t by 2, y is 0. So of course acceleration is going to be 0, because here if I substitute 0, I am going to get this one. So these easy points I am going to plot first. At time t by 2, the acceleration is 0 again. Now what happens over here? At time 3t by 4, the displacement is negative a. So acceleration along y is minus omega square times y, and y is minus a. So I am going to get the value of acceleration as plus omega square a. I am not going to plot this, you will understand. Now the last point, at time capital T, y is 0, because the object is at mean position, displacement 0, so again acceleration is going to be 0. So 3 easy points at time t, this one, right? Now have a look at this one. This is the minimum value of acceleration. This is again the minimum value of acceleration, minimum value. See the magnitude, please do not look at the sign. 3 magnitudes are minimum, but here there is some magnitude which is negative. That means direction is minus y axis. So basically this is maximum magnitude, but since negative sign, that means acceleration is pointing downwards. Here also maximum magnitude, but the direction is along plus y axis. So you have omega square a as the maximum magnitude. So I am going to just simply say that this is plus omega square a, and the same here minus omega square a. So at time is equal to t by 4, I had acceleration negative omega square a, so like this. And at time 3t by 4, I had maximum magnitude, but opposite in direction. So if you look carefully, this is again almost a sine function, but the opposite one. And if you look carefully, look at this one, right? The final expression, I should be saying this one, since acceleration is minus omega square a sine omega t. So actually it is negative of sine graph. So the sine graph ideally is like this, it's opposite, right? Now the same graph would be repeating again for the force, because force again is net force. By the way, net force is equal to mass into this net acceleration. So this is the net acceleration. I will explain you in the next part that how does F net and ma, net acceleration and F net are responsible. So that would be covered in the next one, but please understand that the nature of F and A are the same. So if I simply write down force, the force will also have this kind of nature.